Hello and good evening, CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and this evening's video tutorial is going to be a video tutorial on Lab Activity 4-2. In fact, let me go ahead and update this here. It's actually Lab Activity 4-2, where we're going to be looking at, and let me update this as well here. The layout is identical for Lab 4.2 and 4.1, and so we are just going to be controlling routing updates. All right. So as you can see, exact same topology we had last time, and I've not only have I taken care of all the IP addressing here, I've actually done all of the spin up of EIGRP and OSPF and the configuration required there. So we're actually starting off here at step 3, where we're going to be taking a look at filtering redistributed routes using a distribute list and an ACL. And so that's going to focus on router 2. So if I were to say, do show IP route for the 192.168.8.0, we can see a couple key pieces of information here. The first is that on router 2, and let me make sure, actually I'm on the wrong router here. Let's transition real quickly over to router 1. And let's run that same command. Sorry about that. Do show IP route 192.168.8.0. And there we go. And the information that we're looking for is right here. You can see we've got the administrative distance of 170, indicating that this is an external EIGRP route. Here is our metric value, and it tells you right here that this is an external route. Okay, so what we're going to do now is we're going to go ahead and create an access list, and then we're going to create a distribute list in order to filter some routing information. So, although a distribute list could be implemented on the receiving router, it's usually best to filter the routes from the distributing router. Therefore, on router 2, it says create an ACL called OSPF 20 filter. So let's do that. So IP access list standard OSPF 20-filter. All right, we're going to put a quick remark in here, and this is just going to say filter OSPF routes. And now we need our statement of deny, so we want to stop the 192.168.8.0.0.3.255. And we've seen this before, right? This should look very familiar, this 192.168.8.0. And what we have here is a /22. So the subnet mask is 255.255.252.0. So /22. If it was a 23, it would be 254. But we've got a /22. And that is the summary that we've created over here on the far right-hand side. We've created a summary for these specific 4 networks. And so now what we've done is we've created a standard named access list, and we're going to use this name access list as part of the distribute list to filter the routes from router 2's perspective in the outbound direction, right? So we're redistributing from OSPF into EIGRP, and what we're going to do is we're actually going to have the distribute list reference the OSPF process from which we are redistributing that information into EIGRP. So let's go ahead and let's make that happen. So I've got my deny statement here. Now, what do I need at the end? Now, remember, there's a deny all at the end. So what we want to do is we want to say permit any. Because if we don't do that, we're blocking everything. And we don't want to block everything. We just want to deny that 192.168.8.0 to make sure that the .8, .9, .10, and .11 get filtered out. All right, so where do we do this? Well, we're going to go into the router EIGRP1 process, because remember, this is OSPF being redistributed in the outbound direction into EIGRP. And that's the key. Redistribution is always in an outbound direction. Okay, so we're going to go ahead and say distribute list, and this is where we put the name of our ACL, and so we called it OSPF 20-filter. Now, which direction? Inbound or outbound? Well, this is EIGRP, so we're going to say outbound, and then we can pick an interface, or, as you can see here at the bottom in the all lowercase, we can say BGP if it was being redistributed from connected, EIGRP, OSPF, RIP, static. So we know this is coming from OSPF, and which process ID are we redistributing from? Process ID 1. And in fact, now that I look at this, we are on router 1. So let me pull this back. And we should be doing this on router 2. So quickly here on router 2, I'm just going to say IP access list OSPF, or actually standard, OSPF 20-filter. No remark this time, and we'll just simply say deny 192.168.8.0.0.0.3.255. Quickly trying to get this in here, and then permit any. Now we're back to the router EIGRP 1, where we're going to say not redistribute, distribute list. So distribute list, the name of the ACL, which is OSPF 20-filter, and which direction? It's going to be in the outbound direction on router 2, and it's coming from OSPF process 1. So before we do that, we'll come back over here to router 1 and say show IP route EIGRP, and we should have a series, as you can see there, of EIGRP routing information, and the route that we're most interested in here is this one right here, because that is the summary which we want to go ahead and filter in the outbound direction, which means we are going to remove from router 1 that summary. So let's go ahead and make that happen. So back on router 2 here, I'm going to go ahead and hit enter, and now we'll quickly move back to router 1 and rerun that same show IP route command. And where is that route? It's still there. We'll give it a second here. And now it is, yep, there we go. So we got the neighbor change, right? Because the distribute list was applied. You see we get that pure graceful restart. So now the show IP route EIGRP, the 192.168.8 is gone. And again, remember to wait for that graceful restart. Okay. So that's how a distribute list can be used with EIGRP and an ACL in the outbound direction. And again, it makes more sense in EIGRP to do it at that outbound router instead of allowing router 2 to propagate that information out to router 1, only to have router 1 drop the information. And so let's actually take a look at that. What would that look like? So if I pull this distribute list back up and I say no distribute list, we should see a graceful resync here. I'll give it a second, say show IP route. Yep, we do not see the 8. There we go. So we've got the graceful restart. So show IP route, and there is my summary right here. So if I wanted to deal with this, from the perspective of router 1, I could also do it this way, right? So I could do it in the outbound direction on router 2, or I could come over to router 1 and say IP access list standard, standard, we'll call it OSPF, I'll just say 20, so OSPF 20, and then we're going to say, deny 192.168.8.0 and 0.0.3.255, and then permit, and actually let's leave, we'll leave the permit any off right now. Well, actually no, we won't go that far, so I'll just say permit any, and then what I do is I go into router EIGRP 1 and I say distribute list, excuse me, distribute list OSPF 20, and what are we doing? We're doing it in the inbound direction on router 1 for OSPF, or actually, because we're not doing the redistribution, sorry. All we do is we leave it right there, right? So distribute list OSPF 20 inbound, and now let's see if we get that graceful restart, or if I say do show IP route. Let's see if we've got it out of there yet. There you go. We get that graceful resync. And you can see the 192.168 come back. There we go. It was right here. You can see it was still in there. But then we had the neighbor change, right? We've got that graceful resync. So now when I say do show IP route, that 192.168.8 is gone. No longer in here. So two ways we could do it, but it doesn't make sense to do it at router 1, at least not in this use case here, because if we can stop it at router 2, why would we let it go down to router 1 only to have router 1 have to deal with information that we know we want to block? Okay, so that's basically two ways that you can do it. So now on router 3, we're going to take a look at using the distribute list with a prefix list as opposed to an ACL. So let's jump onto router 3 here. All right, so on router 3, if I say do show IP route, you can see that we have all kinds of information here on router 3 and quite a bit of OE2 information. Let me trim this down a little bit for us here. So OSPF. So show IP route OSPF, and there we go. So we've got 5 OSPF external type 2 routes. And what we're going to do here is we're going to do a prefix list, and we're going to block out the 172.16.0.0 /16 less than or equal to 24. So here's what we're going to do. We're going to say IP prefix list, and they want us to call this EIGRP filter. And then what do we put after this? We could put a description here, right, as a quick comment just to say, whoops, filtering EIGRP routes. And then we're going to call that back. So IP prefix list EIGRP filter. I'll let it use the default sequence numbers. I'm going to say permit 172.16.0.0 /16 less than or equal to 24. Now, this is very important as we learned on Monday night, right? So here is my prefix and length argument for the prefix list. So the /16 plays a critical role. And what the /16 means is that in order to match with this permit statement, everything I'm going to match, the first 16 bits, have to be the same. And I'll get rid of that 0. We're going to put just .x /16. So any route that I'm going to match must start with 172.16 because the 8 bits here and the 8 bits here, as indicated by, we'll draw a little squiggly down around this way, that /16 right there mean those bits have to match exactly, these 8 bits have to match exactly. So I'm going to match anything that starts with 172.16.anything that has a /16 all the way up to a /24 subnet mask inclusive. So I'll match a 16, a 17, an 18. Whoa, that's a terrible slash there. /18, /19, etc., up to and including 24. So anything /16 up to /24 that begins with 172.16, I'm going to match that. Okay, so that's the less than or equal to sign. So we'll take that off of there. Let me clear the screen there. Okay, so we've got the prefix list created, and it looks like I might have already done do show run include prefix. Whoops. Excuse me. All right, so we've got it, so we're good to go there. So now what we're going to do is we're going to go into the OSPF process, router OSPF 1, and again, we're on the wrong router, so let's jump back onto router 2. Let me grab these two statements here. I'm not making my transition smoothly enough between the routers. So exit out. We'll paste these two guys in. So on router 2, I say router OSPF 1. Now, I'm going to do a distribute list in the outbound direction with OSPF. And this is also, again, something we talked about on Monday night, is with OSPF, if you're doing a distribute list, distribute list, and it is inbound, that can only be done on an ABR, on an area border router. If you're doing a distribute list outbound, it can only be done on an ASBR and only on external routing information. Right? So this is one of the subtleties here with OSPF and distribute lists. Is the distribute list in the inbound interface or inbound to the router has to be at an ABR. Well, it just so happens that router 2 is an ABR and an ASBR, right? So we're going to be able to do what we need to do here on router 2, but remember, it will only affect external routing information. And we're going to create a pre-can loopback to prove that, one that is not being redistributed in. So let's clear the screen here. Let's come back. We're in the OSPF process, and so again, we're going to say distribute list, and what is the name of our distribute list? Or I'm sorry, the prefix list is EIGRP-filter. And what direction are we doing this in? We're doing it in the outbound direction. And since we redistributed, we get to pick what process did it come from. Well, it came from EIGRP Autonomous System 1. So on this ASBR, where we're doing the redistribution into OSPF, we're saying my distribute list, which is this EIGRP filter prefix list, is going to take effect on external routing information in the outbound direction from the EIGRP1 process. So before we do this, let's take a quick snapshot here and say do show run, or do show IP route, and then OSPF. All right, so that prefix list, which said 172.16.0.0/16 less than or equal to 24. Which of these OE2 routes, because these are the ones being redistributed, is that going to match? Well, that starts with 172 and 16, and it's a 24. That matches. 172.16, it's a 24. That matches. 172.16.12, it's a /24. That matches. So these three routes all will be matched by the prefix list, and all three of these are being redistributed. And where are they coming from? So here's the 172.16.1. Here's the 172.16.12. And here's my 172.16.2. So all of this routing information here, these three routes, are in EIGRP AS1. We've redistributed them into OSPF, and now we're going to use this distribute list to constrain what is being redistributed from EIGRP into OSPF. Now, will these still be redistributed? Absolutely, because they're not going to be matched by that prefix list statement. So here's what we need to do. We'll go back over here to router 2, and we're going to hit enter. Let's come back to router 3 and see what we've got. And we're actually permitting here. Let me take a look at this real quick, because it's got a permit statement for those routes. So only those routes should be getting redistributed, but we are still seeing the 192.168s. So hold on one second here. Let me transition back to router 2. Let's make sure we got everything right. Do show run section OSPF. And we're redistributing the subnets. We've got the distribute list EIGRP filter outbound EIGRP1. And so we are redistributing, and the filter list isn't working. Let's take a look at our prefix list. Do show run include prefix. Let's make sure I don't have a typo here. And we are permitting those 3 routes and only those 3 routes. And the prefix list at the end has an implicit deny. So I'm curious here. Let's see if we still see those routes. We do. So only those 3 routes should be allowed. The 192.168.48 and the 192.68.70 should not be getting redistributed here. And so that is definitely odd. Let me see. Do show run. Take a look at the EIGRP config here. Distribute list EIGRP filter out. And so that should definitely not be there. Router EIGRP1. Did I accidentally apply it here? So no. Distribute list EIGRP filter. And let me see if I had it in the wrong location. That didn't solve the problem. So do show run, whoops, section OSPF. So why are those routes? So let's do a little troubleshooting here. We've got our summary, the redistribute statement. EIGRP filter is in the outbound direction, and that is correct. EIGRP. I'm convinced I must have typoed something here. EIGRP-FILTER sequence 5 permit 172.16, but it should be denying everything else that's getting redistributed in. All right. In cases like this, what I'm going to do is I'm going to say router OSPF1. Excuse me. We're going to remove the distribute list. And I'm going to remove the prefix list. All right, and I'm going to start from scratch. So we're expecting something to happen, and we're not seeing that happen. So R2, step B here, step 4, substep B, we're going to identify the networks to advertise. So let's go back to the drawing board here. So IP prefix list, and we're simply going to call this EIGRP-filter. And we're going to leave the description out. I'm just going to go right to the 172.16.0.0/16 less than or equal to 24. And that statement looks good. So then we'll jump into the router OSPF1, and we're going to say router OSPF1, and we'll give the distribute list prefix. Oh, did I not have the prefix keyword in there? Aha! That was the problem. And this is interesting because I typically warn students to make sure that you put the word prefix there. If you don't put the word prefix there, what is it going to take that as? It's going to take it as the ACL, as a named ACL, and it is not. So distribute list prefix, now we're on track. EIGRP filter, I apologize there. EIGRP filter, outbound, EIGRP1. So now we come over to router 3. And now we're going to see what we would anticipate we would see, which is all of those 192.168s. Well, the 48 and the 70, those are gone now, because we're only allowing the 172.16s, which we have identified. And that 192.168.8, remember, that's an intra-area OSPF route, so that's not affected by the distribute list, because the distribute list is only for external routing information. Now, when we did the prefix list, remember, we said /16 to /24. So to prove that it's only going to impact redistributed information, I'm going to go ahead and I'm going to go to router 2, and we're going to create interface loopback 200. And I'm going to say IP address 172.16.3.1. We'll make it a /24. And let's go ahead. We'll put it in there with... we'll just make it part of the area 0, and I'll say IP OSPF1 area 0. And do show run. Let's make sure we have a Well, actually, no, we're good there. So we should be good. So now I've originated this route here, and let's go ahead and say IP OSPF network type is going to be, whoops, point to point. So it'll show up as a /24. So now let's come over to router 3, and I'm going to say do show IP route OSPF again. And we do not see the 172.16.3. Let me confirm. Do show run interface loopback 200. IP OSPF 1 area 0. So we should be seeing this network do show run section OSPF. So we've got the summary address statement and we've got the network statements. And I've enabled it on the interface. Let me do this, because that should show up here. And maybe we didn't wait long enough. No, it's not showing up down here. And it should, because we've got an area 0. We're good there. IP, let me make sure I don't have any mistakes here. IP OSPF 1 area 0. It should not be getting filtered out. Because, it is going to, yeah, actually, I think it is going to get filtered out because it's the ASBR, but it should only be external routing information. So let me try this. Let's actually do this. I'm going to say no IP OSPF 1 area 0. And this shouldn't make a difference, but I just want to make sure. Router OSPF 1, I'm going to say network 192.168.3.0.0.0.255 area 0. And let's see if that changes anything. It shouldn't. And it's naturally being originated in OSPF. So why is that not showing up? Do we have, there is no distribute list, or wait a second, to show section. Am I actually filtering something out here? I am not. So do show run section, well, actually we've seen that. Yeah, that's interesting because that should be showing up unless I'm looking by do show run interface loopback 200. Do show IP OSPF interfaces, and actually we want to do the brief. So let's see if it's picked up here. So it's not even picked up as an OSPF interface. All right, this definitely has me confused because do show run interface loopback 100. And that is, and we're not using 172.16.3 anywhere else. So that's not it either. Do show run section OSPF. Am I missing something? Oh, you know what it is. The reason that loopback, so the loopback's got the wrong IP. Loopback 100 does. Int loopback 100 should be 172.16.100.1, but this is not causing that other route to not be advertised. So do show run or do show IP OSPF interface brief. So yeah, because it should be running on loopback 100, but why do show run section OSPF? Why is it not running? Because I put in 192.168. So let's do this. I should be able to say interface loopback 200 IP OSPF 1 area 0. And that should work. And let me take out the router OSPF 1 statement here, or the incorrect network statement that we have here. You see I put the 192.168.3, and I wanted that to be 172.16.3. So do show IP OSPF interface brief. Now we've got loopback 200 in play here. So now that the process is running on that interface, I'll come back over to router 3. And again, what we're trying to show here is that it's only external routing information that's going to be impacted by the statement that we have there, which is, or by the distribute list that we're using. So we should see, well, we see OIA, but we still don't see, and that is really interesting. We should be seeing that 172.16.3 because it's in area 0. And it's not external routing information. I guess really we could look at this and say absolutely 100% that should end up getting blocked by that the prefix list that we did before, because it begins with 172, then 16, and then we've got anything here and anything here, and it's a /24. However, it's inter-area OSPF, so it's not going to get blocked. However, again, that's interesting, and I'm wondering if it's because, yeah, no, that doesn't make any sense. It should be, it's external routing information, so why? And let's run this again and make sure. 172.16.3.1, point-to-point in area 0. Let me change the area. Let's go ahead and say, let me go back into interface loopback 200. Again, sorry for the sidebar here, but I want to see IP OSPF1 area, we'll say 200. And then do show IP OSPF interface brief. And we're in area 200. Now when I come over here, and that is really weird. We're not getting that, and we should be picking that up. Because again, router 2 is an ABR and an ASBR. So on router 2, if I were to say do show, or actually do show IP OSPF, we're going to see that it is an area border router and an autonomous system boundary router. And we are seeing other intra-area routes. We're picking up, well, actually, this is coming, well, because router 3 has an interface in this area, and it's the null 0 route anyway for the OSPF 20. So that is very interesting, unless there's something else here. And let me do this. Let's get out, well, I guess, well, no, we're trying to prove that 172.16 range. So again, we'll leave it the way it is, but yeah, this one is being advertised without any issues at all. So I'm not sure why, do show run interface loopback 200, why that is not being advertised into OSPF area 0, unless there's something else that I've configured that I overlooked. All right, so we're going to move on. So step 5, we're going to talk about filtering redistributed routes using a route map. So let's move back to router 1 here. And if I say do show IP route EIGRP, you can see that we've got quite a few external EIGRP routes still, the 20, 25, 30, 35, 40. And so right now we're going to be targeting 25 and 30. So now we're going to sort of take the next step up to using an access list with a route map. So, and we're going to do this on router 2. So on router 2, what we're going to say is IP access list and standard, and we're just going to say R3-ACL. We'll leave the remark out, and I'm going to say permit 192.168.25.0, and this is a /24. And we're going to say permit 192.168.30.0. So this ACL is going to match those two. Now you'll notice there's no permit any at the end because it wouldn't make sense, but there is an implicit deny all or deny any at the end of this. So that is our standard ACL. So now we're going to come back and say route map, and we're going to call the route map R3-filter, deny 10. And then we're going to throw a description in here that says RM filters R3 OSPF routes. All right. Now, we've got the description in here. We're also going to have a match statement because we are going to deny match IP address R3-ACL. So what we're going to be doing here is we're going to be denying, and it says exit, but you don't actually have to do exit. I could simply call this back up and then say permit 20, right? And it gives you a little description field here, and it says permits all other R3 OSPF routes, right? So what we just did with this route map, and let me say do show run and section or begin route map. All right, so here is the route map that we have right now, and we're going to be matching the IP address, which is actually an ACL, right? So match IP address, which is an ACL, named R3-filter. And why do we have... And actually, this is incorrect here. I don't remember typing that in. So let's do this real quick here. Let me go ahead and clear the screen. And we're going to say no. Let me back out of the route map here. We're going to say no route map R3 filter. So we're going to wipe out this route map real quick, and then we can quickly recreate it. So we'll say route map R3-filter, deny 10, match IP address R3-filter. Or is it R3-ACL? Sorry about that. Yeah, it's R3-ACL. I think that was where it may have come into play, where I typed it wrong. So R3-ACL, and then we're going to say route map R3 filter permit 20, right? So now let's take a look at that route map again. Do show run, begin route map. All right, so here is the route map. And we're basically going to be denying, and let me change the color here real quick. We're going to be denying anything that matches the R3 ACL, and we know that it's the .25 and the .30, right? Then this empty statement here is basically permit all or permit any, however you want to look at it. It's an empty statement, but it means permit everything else because at the end of this route map, there is an implicit deny any at the end. So we're going to permit everything before we deny everything. Because we want to make sure that while we don't want this information here for 25 and 30, we do want everything else to make its way through there. So let's go ahead, clear the screen, and we've got the route map set up. So what we need to do now is we're going to go into router EIGRP 1, and we're going to say redistribute OSPF 1, and route map is R3-filter. And the metric, we'll just assign a bogus metric here, 1,000, and we'll do 100, 1,500, 1, and 1,500. And 1,500 was too high because that's the reliability, so we'll say 255, and or we'll say 1, 255, 1,500. That should do it. There we go. All right, so we've done our redistribution statement. We've called the route map. Now let's transition over to router 1, who had all of these EIGRP routes, including 25 and 30. And now when we take a look, you can see that 25 and 30 are now gone because we use that route map statement. So now we're going to transition over to step 6. It says filter redistributed routes and set attributes using a route map. So back to router 2 we go. And we're going to create a prefix list here. We're looking at some OE2 routes, and we're going to be setting the metric type to type 1. So I'm going to say IP prefix list, and actually we're in this sub-configuration mode here, so we'll have to type it all out. IP prefix list R1PL, and I'm going to permit 172.16.12.0/24. So again, the first 24 bits have to match for this permit statement to match on a route, which means it has to be 172 followed by 16, followed by 12, followed by anything, and be a /24. Well, if it's got to be a /24, we know that that anything is going to have to be the network ID of 0, or else it wouldn't be a /24. So the prefix list has been created. Now let's go ahead and say route map, and we're going to call this just R1 filter. We're going to say permit 10. Now we're into the area where we can match on the IP address. Now this is critical again, right? Prefix list, and the name of my prefix list is R1-PL. And what do I want to do? Well, I'm going to do a couple things. I'm going to set the metric to 25, right? And then I'm going to set the metric type, if it matches, to type 1. Now, again, you see it shows you that you can say exit. However, we don't need to say exit. I can simply just come back and say route map R1-filter, and then permit 20. And again, this just permits all other routes instead of that implicit deny all at the end. So from here, we move into the OSPF process because that's where we are doing the redistribution of EIGRP into OSPF, and we're going to apply that route map here. So I'm going to say redistribute EIGRP1 subnets, and then route map R1-filter. So again, before we do this, let's take a quick look over here on router 3, and you can see we've got the 172.16.12.0/24 there. Let's see, does this route map have any impact on what we see? Absolutely it does. So you can see right here, we now, oops, sorry about that. I guess I'll go underneath it here. So we have an OE1 for 172.16.12, and take a look at the metric. We set it to 25, and then we're going to add 1 for the actual cost, and so now it is 26 is the metric, right? What is the typical default seed metric? It's 20, but we set it to 25. So now, from router 3's perspective, he sees that router 2, and this is router 2, is advertising to him that if you want to get to, and where are we at? The 12. This 172.16.12 right here. If you want to get to this network, you're going to include the costs that you would incur. And so again, we set the cost to 25, right? And then it adds an additional 1 onto the cost. And that's why we see an OE1, right? Where it cares about the internal costs that it's going to incur. So we've got this outgoing interface right here, which is a fast Ethernet interface, right? And remember, 100 megabits per second for OSPF is the default reference bandwidth and has a cost of 1. So R2 sets the metric to 25, sends it in, and R3 says, yep, I've got this outgoing interface with a cost of 1 to get to here where this network is directly connected. However, I have to add that 1 onto the 25 that was set by router 2, so I get 26. And that is how we come up with that OE1 metric cost. And again, this is a fantastic activity because this is really where you can get into some really fun scenarios about redistribution, setting the metrics, setting the metric types, setting the costs, and really sort of digging in to the layer 3 traffic engineering. All right, well, this wraps up Lab 4-2, Controlling Routing Updates, and I will see you all on Monday night.